Let's prove midpoint theorem. So the statement of the theorem is that the line segment joining the midpoints of two sides of a triangle is parallel to the third side. So first thing is we need to draw the diagram, and please draw a diagram which is not an equilateral triangle. So we have, say, ABC, and so we have point P and Q, which are the midpoints. So we will extend something like this. Then we have, okay, we'll join this and we'll call this as point T. So this is your diagram, right, wherein we have these two sides and these two part of the length are equal. So let's talk about the diagram. Consider triangle ABC with P comma Q being midpoint of AB and AC respectively. So this means AP is equal to PB and AQ is equal to QC. Next is we need to prove that PQ is parallel to BC. Now let's do a bit of construction. So we'll extend PQ to T such that CT is parallel to AB. So this entire length is parallel to this. So we'll draw such a diagram. Now, how does this help? So I'll give you guys clues and you guys can go about doing this. First is we need to prove that triangle 1 is congruent to triangle 2. So it's your job to prove this. So we have consider triangle APQ and triangle CTQ. Okay, so one thing is we have AQ is equal to QC. That's kind of obvious. And we have vertically opposite angles. Angle PQA is equal to angle CQT. Vertically opposite angles. And the last thing is we need to tell that these two angles are equal. Why are they equal? Well, if you think about it, it's equal because angle PAC is equal to angle QCT. I'll take this as Q. Reason, AB is parallel to CT and these are alternative interior angles, is it not? Right? If you are not able to figure that out, have a look at this diagram. You have one parallel line, another parallel line, and that's your transversal line. So these two angles are equal. Okay, so what else? So therefore triangle APQ is congruent to triangle CTQ by ASA congruency. Okay, how does this help? Well, we can tell that AQ is equal to TC by CPCT. So now, okay, now we'll talk about this as AP is equal to TC and AP is equal to PB, right? So just a second. AP is equal to PB and AP is equal to TC also. So what can we conclude from this two? We can conclude that TC is equal to PB. So this length is equal to PB. And now what can you tell? Quite simple actually. Since, okay, let me write it off. Consider PTBC. PTCB actually. CB. Since we have a side being equal and parallel of this particular quadrilateral, so what can we conclude? As PB is parallel to TC and PB is equal to TC, PTCB is a parallelogram. And since this is a parallelogram, we can conclude PT is parallel to PC, or PQ is parallel to PC, opposite side of parallelogram. And we have proved it. Okay, so this is your proof of the midpoint theorem. So very simple. You need to construct so that we have two parallel lines. Because they are parallel, we will be able to prove these two triangles are congruent. And with that congruency, we can prove that opposite sides of a quadrilateral are equal and parallel. And with that, we can conclude this particular thing.